Hello students, I am here with another video on the topic called refraction. Children, I hope you are safe and sound along with your family members, right? And you are continuously watching these videos and you are going through the content. Alright? Now let us start the proceedings of this video. Children, in the last video we were discussing some important concept of what is called the topic refraction of light. So I am starting this video with what is called, one optical illusion. If I take this as beaker, I am taking water. Now this is supposed to be a point. Let us see if it is air. This is medium number A called air. This is medium number B, let it be water or whatever be. See children, first possibility, if the ray is going in this manner, it will go straight. Alright? No change will be there in the path. Now another possibility I am taking, if you are somewhere here, the ray will hit, it will go away from the normal, it will bend in this manner. If you see from here, it will appear as if the ray is coming from here. So children, it is very interesting to note that if this point is taken as A, this will be visible at A dash. Alright, this is optical illusion, right? So what is called a simple proof is there. The refractive index, absolute refractive index, I must write B with respect to A, which can be further written as mu. It is called real depth divided by apparent depth. Or mu is equal to what is real depth. This point, suppose I take this point to be P, real depth is PA, the apparent depth is PA dash. So it could be PA divided by PA dash. A simple proof is there. So remember the formula in this format. This is important from the point of view of numericals. So mu is equal to real depth upon apparent depth. The proof I shall be giving you later on, right? Now let us move further. Children, as far as the refraction of light is concerned, the best examples in our life, they are the lenses basically. The concept is not new for you, you have already done in the previous class. I am talking about the two lenses. The one is called convex lens, the other one is called concave lens. So let us now focus in this video especially on the lenses. Children, I have given you one assignment, one homework, sheet number 1 I provided. So I have already covered, I have already given some questions based upon lenses. So let us do without any formality the concepts of lenses. Alright, let us now see. Kindly see the board. Children, you know very well, this lens which is thin from the corners and thick from the middle is called convex or converging lens. Converging lens. This lens, we have got two surfaces, refracting surfaces. Light can come from here, even from here. But we have to follow the traditions. So we are supposed to throw the light from left to right. That is this direction. And children, very interesting to note, the other things, important definitions we have already done in reflection, they are same. For example, this is called principal axis. This point is called optical center. In the mirrors, the middle point used to be the pole. So this is called optical center. Children, we have got principal focus over here. If it is a biconvex lens, biconvex means if these two sides they have got same radius of curvature, this is called biconvex lens. In our syllabus, the 99% problems are based upon biconvex or biconcave lenses. So here, if you throw the light from here, it will be focused, it will be passing through this point called principal focus. Children, distance CF is called focal length F. Similarly, if you throw the light from the right, it will be focused at this point. This point on the principal axis is called principal focus. Alright, so we have got principal focus both the sides. Other points you can take as per your choice, as per your convenience. Say for example, if it is 15 centimeter, you can mark another point called 2F, right, at 30 centimeters. Similarly, you can have another point over here at 2f. Alright, these are the features you know very well as far as the convex or converging lens it is concerned. Now let us come to concave lens or diverging lens. So this lens, children, it is called concave lens or diverging lens. It is the optical center called C. Both the sides we have got principal focus F. The distance CF is focal length. Distance CF is called focal length. Similarly, here also CF, it is called the focal length of the lens. So remember, children, this is called convex lens and this is called concave lens. Now, another important question: what is the utility of these lenses in our life? You know the answer very well. The lenses are basically used for the formation of images, different types of images, maybe real, maybe virtual. So let us, before moving ahead, let us go through some basic rules which are involved in the formation of images. Alright, so in this diagram only we shall be discussing the rules. Let us start with convex lens. Children, option number 1, point number 1. If an incident ray which is parallel to the principal axis. Remember, I repeat, an incident ray coming parallel to the principal axis after the refraction will pass through the principal focus. This becomes rule number 1. You can even take the ray from here. After the refraction, it will go in this manner. This becomes rule number 1 forever. What will happen here in case of concave lens? If you take incident ray parallel to the principal axis, it will bend in this manner and it will appear as if it is coming from principal focus. If you take incident ray here, it will bend in this manner, it will appear as if it is coming from here. This is rule number 1. What is rule number 2? Rule number 2 is the reciprocal of rule number 1. That is, if you take a ray through, I just make some correction here. If you take a ray through principal focus, like I am taking in this manner, what would happen after the refraction? Children, it will become parallel. Similarly, you can take another ray through this incident ray through principal focus, it will also become parallel. Alright? Similarly, if you take a ray through principal focus, what would happen? It will just become parallel, right? In this manner. Okay. Another important third point is, basically, if you take, third choice I am giving you, if you take any ray through optical center, right? If you take any ray through optical center, that is, if you take the ray through optical center, it will go straight, nothing will happen. You can even take the ray from here, it will go straight, nothing will happen. Similarly, if you take the ray through optical center, it will go straight. If you take the ray, it will go straight like this. So children, these are the basic 3 rules you are always supposed to remember when you go for making the different types of images with the help of these lenses. Alright, so next I would like to discuss the formation of images by these lenses. Alright, let us start with convex lens. See children, if it is a convex lens, I mark different points, say optical center, F, 2F. Children, if it is infinite, first option, keep object at infinite. Number 2, beyond 2F. Number 3, at 2F. Number 4, between F and 2F. Number 5, at F. Number 6, between C and F. So remember, these are the in all 6 possibilities of formation of images by convex lenses. Always remember, in these 5 cases, image is real and inverted. In this case, the image is virtual and inverted. Children, as far as the concave lens is concerned, you know very well, it only forms the virtual image. We have got just 2 possibilities. Either you keep the object at finite distance or you keep the object at infinite distance. So this lens always makes, always make virtual and erect image. Alright, these are the different image formations. Okay, I just take for example, I am just making one image for you, one real and virtual. One virtual with the help of convex lens. Case number 1. Say I take a ray. This is F, this is F. I am placing the object to be here. A ray will go parallel to the principal axis, will pass through the focus. Another one I am taking through optical center. They will cut here. The image is formed at this point. AB is the object, A dash B dash is the image. You know very well, need not to tell you. Image is real, inverted, right? It is on the other side, okay? And it is smaller in size. So please, when you go for making the images, properly mark the distance 2f also. It will tell you different 6 possibilities, okay? Location wise I am talking about. What is the exact location of formation of image, okay? Now I shall be telling you the formation of virtual image with the help of convex lens. Children, if it is a convex lens, the optical center, the principal focus, okay? I keep an object here, somewhere here. What would happen? If a ray is going, parallel, it will pass through principal focus in this manner. F is here. I take another ray through optical center, it will go in this manner. Children, these two rays are diverging in nature. They will not be meeting anywhere in this region. If you see from here, it will appear as if the ray is coming from here. So the final image is formed at this point. If AB is taken to be the object, then A dash B dash will be the image. So this is how exactly the virtual image is formed with the help of this convex lens. Alright, children, next thing, what is called the sign conventions. You know very well, we have done under reflection the different symbols which are used. Like I am talking about U, V, F, H dash, H, M. So I must tell you, the first point, as far as the sign conventions they are concerned, 3 points I am taking, 3 points I am telling. Number 1, all the distances are measured from the optical centers of the lenses. Number 2, the distances which are measured in the direction of incident light, that is from left to right. That is, in this direction they are taken positive, and in this direction they are taken negative. So what should be the point? The point should be read as the distances which are measured in the direction of incident light are positive, otherwise negative. Last point, the distances which are measured above principal axis. For example, if object is placed above principal axis, it is taken as positive. If we keep object below principal axis, it will be negative. If image is formed here, it will be negative. Below principal axis, if it is formed here, it will be taken as positive. Right? So, universal laws for both the types of lenses. Okay? Alright? Now, remember U. What is U? U is the distance of object from the optical center. What is V? The distance of image from the optical center. What is F? The focal length of the lens. What is H dash? The size or height of image. What is H? The size or height of object. What is M? M stands for magnification. Alright? Let us do what is called lens equation or lens formula. Children, you have already done mirror formula. There is a minor difference between mirror formula and lens formula or lens equation. Lens formula is 1 upon F is equal to 1 upon V minus 1 upon U. Children, in physics, in optics, this is popularly called lens equation or lens formula. Remember it. You know very well the meaning of F, V, U, etc. Alright? Now, another important physical quantity about which I am going to tell you called magnification, represented by M. Children, very interesting to note, the definition exactly it is same you have already done under the topic called reflection. M is defined as H dash upon H. That is the size of image divided by size of object. Alright? And very interesting to know, M can have another formula, H dash upon H, or could be equal to V upon U. Children, it is point to be noted here. In the reflection, a minus sign was there, but here in case of refraction, minus is not present at all. So please make it a point, remember it forever. You can have some other expressions also, we have already done for the mirrors. Like once you multiply both the sides by u, by f, once you multiply it by both the sides by u. This I am talking about. Children, remember m is equal to v upon u. This formula includes u and v. If you want to express magnification using focal length, then I am telling you, you have got two different ways. Once you multiply both the sides by u, another time you multiply both the sides by v and go for simple calculation work. You will be able to find out the final results in all. Alright? So children, I think this is enough for this video. There are some little bit important concepts I shall be going for that, like the power of the lens and if what happens when you keep the two lenses in contact with each other. So these things will be discussed in the next video. Thank you so much. Thank you very much for watching these videos. I think these videos are going to be very helpful for you. So under the conditions, these lockdown conditions, please be very attentive. This time is going to be the fruitful time for you. You are at your home. You please make a schedule for self-study and take the things seriously. Stay home, stay healthy. Thank you so much. God bless you.